Welcome to the Mind and Matter podcast. I'm your host, Nick Jikomis, and today I'm speaking with Dr. Saoirse O'Sullivan. Saoirse holds a PhD in physiology, and she was a professor at the University of Nottingham in the United Kingdom for many years. Her lab studied the physiological effects of cannabinoids. Saoirse and I discussed some of the physiological effects of cannabinoids in the body, including endogenous cannabinoids that our own bodies produce, and plant cannabinoids associated with the cannabis plant, such as THC, CBD, THCV, and CBG. We covered a number of areas of physiology and systems in the body, including inflammation, brain injury, the blood-brain barrier, gut health, and the cardiovascular system. Towards the end, Saoirse also described why she eventually made the transition from academia to the private sector, and what motivated her to make that decision despite having been a successful researcher and having been granted tenure as a professor. As always, if you enjoy the content of this podcast, please like, share, and subscribe. You can give us a 5-star rating on Apple Podcasts, and even if you just share it with one friend, that can be really impactful. If people find the episodes interesting and they share it with people who they think will find it interesting, that really does help get the word out about the podcast. Today's show is brought to you in part by Dosist, an all-natural cannabis company specializing in dose-controlled cannabis products made with plant-based ingredients. To learn more about Dosist, their products, and where they are available, please visit their website through the link in the episode description. This episode is supported in part by Athletic Greens. Their main product, AG1, is a comprehensive and convenient daily nutrition product containing 75 vitamins, minerals, and whole food-sourced ingredients with less than 1 gram of sugar per serving, no nasty chemicals or artificial anything. It's gluten and dairy-free and compatible with paleo, vegan, vegetarian, and ketogenic diets. AG1 is a quick and convenient way to supplement your diet to help ensure your body is getting the nutrients it needs. It comes in powder form, and you can mix it in water and drink it, or you can put it into a smoothie or a shake or something like that. I mix it into water and drink it with the first meal of each day, and it's super convenient. If you go to athleticgreens.com/mindandmatter, Athletic Greens will give you a free 1-year supply of vitamin D and 5 free travel packs with your first purchase. Their vitamin D product comes in tincture form, so you just take 1 drop each day. A large fraction of the population is actually vitamin D deficient, especially in winter months when we get less sun exposure, and vitamin D is super important for the proper function of the immune system and for a variety of other things. And there's even evidence indicating that vitamin D deficiency is correlated with more severe cases of COVID-19 in those who get infected. Every time I go into the doctor each year for a checkup, I'm always told that vitamin D deficiency is very common and I should be supplementing on a daily basis. So visit athleticgreens.com/mindandmatter or click the link in the episode description. You'll get a free 1-year supply of vitamin D with your first purchase. And with that, here's my conversation with Saoirse O'Sullivan. Saoirse O'Sullivan, thank you for joining me.
You're very welcome. It's lovely to be here.
Can you tell everyone a little bit about who you are and what your background is, what you're doing today?
Yeah, sure. So my name is Saoirse. I started cannabinoid research nearly 20 years ago in 2002. I took a job at the University of Nottingham, which had a really thriving cannabinoid research group at the time. And I started investigating how cannabinoids affect the vasculature. And that's the background that I came from, was a cardiovascular background. It was only supposed to be a 3-year job, but I got hooked on cannabinoid pharmacology and basically never left the university until 2019. So I stayed there for 17 years. My research basically grew, expanded into lots of different research areas in terms of indications for cannabinoid use, and also moving more towards human trials. So I started doing healthy volunteer studies and small proof of concept clinical trials. So I got a lot more translational as my career went along. And then in 2019, I made the leap. After just becoming made professor, I decided that actually what I wanted to do was leave academia and work in industry. So for 2 years, I worked as an independent consultant, as a scientific advisor to lots of pharmaceutical companies. And one of those was a company called Artello Biosciences, who are based in LA. And I have just very recently taken up a permanent position with them as their vice president of Translational sciences. So it's my job to basically turn cannabinoid science into new medicines, which has really always been my objective, is to try and get the science that we have and the good evidence basis that we have into clinical trials, and just trying to get more research being done. So that's who I am and where I am now.
Yeah, so I think we'll circle back to some of that towards the end. In the beginning, let's briefly spend some time for people that don't have as much of a background in cannabinoids. What are cannabinoids? In particular, can you describe some of the major plant and endogenous cannabinoids and what the similarities and differences are?
Yeah, so there are three kind of broad categories of cannabinoids. There are the ones that come from the plant, from the cannabis sativa plant, and they're known as phytocannabinoids. And then there are cannabinoids that we make in our body, and they are known as endocannabinoids because they're made endogenously. And then there's another group of compounds which are synthetically produced, and they're called synthetic cannabinoids. But they all basically, the definition of a cannabinoid, which is fairly loose and up for debate, is that it either comes from the cannabis plant, or that they bind to cannabinoid receptors, or that they are structurally similar to one of those two things. So really, it's quite a broad umbrella term that encompasses quite a lot of very structurally diverse compounds, who also have very diverse pharmacology. So you can't say that all cannabinoids work in the same way. They're very, very unique. So in the phytocannabinoids, the major ones that we know about are tetrahydrocannabinol, which is probably what you would call in the pharmaceutical world as the active pharmaceutical ingredient of cannabis. It's the most abundant chemical in most cannabis varieties. And it is the part of the plant that will get you high. It's the only chemical really in the plant that binds to receptors called CB1 receptors. And so most of the biological effects of cannabis come through that. And then there's the less abundant cannabinoid, which is cannabidiol. There's an awful lot of interest in cannabidiol recently. It's quite different pharmacologically. It doesn't bind to cannabinoid receptors really with any great affinity, but it has some really unique and interesting pharmacological properties that make it quite an interesting drug that's being investigated. And then there's lots of minor phytocannabinoids, we call them, because they occur in really quite low levels in the cannabis plant. So there are dozens of these, and they all, again, have quite a unique pharmacological profile and are being investigated. So some of the ones that people are interested in are cannabigerol, cannabichromene, and some of the varins, so tetrahydrocannabivarin, cannabidivarin. So there's multiple compounds in the cannabis plant. It's really quite a complex group of chemicals. And then for the endocannabinoids, we've got two main endocannabinoids. We have anandamide, which is like our body's version of THC. So it has a fairly similar profile to THC in that it binds to the CB1 and CB2 receptors, and it brings about a lot of similar actions in the body as THC does. And then we also have another compound called 2-AG, 2-arachidonyl glycerol, which is also a CB1, CB2 agonist. And then we have a whole load of other compounds, which are sometimes called endocannabinoid-like compounds, like palmitoyl ethanolamide and oleoyl ethanolamide, which don't bind to cannabinoid receptors, but they do kind of act on the family of molecular targets that cannabinoids bind to, or they can competitively occupy the enzymes that break down endocannabinoids normally, so they can increase cannabinoid activity and indirectly cause cannabinoid receptor activation. So there's probably about maybe 6 or 7 endocannabinoids that we make in our body that we're aware of. It's a list that grows. And then synthetic cannabinoids, there are hundreds and hundreds of them. You know, they've been developed since the 80s originally as research tools, really, so that we could understand cannabinoid receptors better. And that has gone off in various directions, some of which are positive and some of which are very negative. So yes, but you can synthetically synthesize any compounds to either selectively inhibit or antagonize the cannabinoid receptors, either within the brain or peripherally restrict them. So there's a whole host of other compounds out there that are being developed in a pharmaceutical sense as well, which could be very therapeutically beneficial. So as I said, it's a big family of compounds, and they're all quite different. So it's hard to, the concept of a cannabinoid is quite a broad thing.
I see. So we'll spend most of our time talking about some of the plant cannabinoids. Before we get there, I want to talk about endocannabinoids a little bit. Without going into excruciating detail, for someone who's unfamiliar, what would you say are sort of the broad physiological functions of endogenous cannabinoids in our body?
So it's quite a hard question, because it depends on what body system you're talking about. You couldn't kind of just generalize a single biological response, because it depends on the tissue in which you're talking. So in blood vessels, they cause vasodilatation. In neuronal tissue, they have an impact on neurotransmitter release. In peripheral nerve terminals, they affect neurotransmitter release. In adipose tissue, they affect the amount of adipose tissue that's there and energy storage, same as in the liver and in skeletal muscle. So the impact of endocannabinoids is very tissue specific, but what you can say is that they're found in every cell. They are the cannabinoid receptors, so the proteins on the cell surface to which they bind are found in every cell. So the CB1 receptor is everywhere. So they have functions in almost every cell, but it is dependent on what tissue you're talking about. You couldn't generalize their role.
I see. Is it fair to say that in most of the cells and tissues that they operate in, that they're playing some kind of homeostatic function, preventing things from going too far in one direction or the other, or is that only true in some cases?
It's a word I've heard used a lot. I mean, so yes, in that when there is cell damage, so for example, if a cell is starved of oxygen, or if it is being has oxidative stress, or there's actual physical injury to a cell, then there will be a release of endocannabinoids, and there will be an upregulation of cannabinoid receptors, particularly the CB2 receptor. So the CB2 receptor is known for being enhanced when things are going wrong. And primarily the concept, the idea is that is supposedly in a protective fashion. So that's what we definitely think, is that these things are upregulated in order to try and resolve the situation, which is true of many other compounds. I mean, that's what our body does. If something goes wrong, we upregulate different, chemicals in order to try and make things right again. So I don't think they're unique in that ability. And yes, that's definitely the concept of what they do.
Interesting.
But there are times when upregulating the endocannabinoid system is not necessarily a good thing. So, like any system, there's always a balance where too much of anything is usually not a good thing. And again, that's true of almost any chemical signaling system in our body.
I see. So you mentioned that when there's physical damage to cells, you tend to get release of endocannabinoids, although you'll get release of other things as well.
Yeah.
I know that there's been quite a bit of research for the different plant cannabinoids and other cannabinoids with respect to their potential to have neuroinflammatory or neuroprotective effects, or I should say anti-inflammatory effects. And you also mentioned the CB2 receptor. Can you talk a little bit about what we know there in terms of CB2 receptor and inflammation, and which cannabinoids tend to have anti-inflammatory or neuroprotective effects?
Yeah, well, the short answer is pretty much every cannabinoid that's been tested does tend to have some kind of anti-inflammatory effect when tested in a cell system. I mean, most of the experiments that we're talking about, and experiments that I've done myself, are in cellular systems. But in general,
mean like a petri dish with cells.
Yeah. So cell culture dishes where we grow up cells, whatever our cell of interest is. And then you treat them, you do something to damage them, and then you treat them with cannabinoids. Or sometimes it's an organ, a piece of tissue. But in general, any cannabinoid I've ever tested, and that's including phytocannabinoids or endocannabinoids or synthetic cannabinoids, have an anti-inflammatory effect. I mean, some to more extent than others, but it seems to be a fairly general characteristic of cannabinoids is that they are anti-inflammatory. It's not, and the CB2 receptor is well known for being anti-inflammatory, and CB2 agonists have a very anti-inflammatory effect. And there are some pharmaceutical companies looking at whether or not they can use CB2, chemicals which have been designed just to activate the CB2 receptor for different kinds of situations of organ damage, like chronic kidney disease or chronic liver disease. But the anti-inflammatory effect and antioxidant effect aren't always through the CB2 receptor. So I think there are other mechanisms by which cannabinoids are anti-inflammatory and antioxidant, and we don't always understand what they are. Sometimes it can involve GPR55, which is a receptor that it's been identified that cannabinoids can act through. So it's not always just through through CB2 is what I want to point out, is that there are multiple ways in which, and some of it we still don't actually really know how they're working, but they are anti-inflammatory.
So almost every cannabinoid that's been tested has some kind of measurable anti-inflammatory effect, at least in the lab. And inflammation is, well, it's something that we all experience to some extent in different ways, but it's a very broad term. CB2 receptor is a major player in inflammation, but there are many other ways to have inflammatory or anti-inflammatory effects. And it sounds like each cannabinoid probably has, to some extent, unique or partially unique mechanisms by which it has this kind of effect, meaning they're not all going to act on different forms of inflammation the same way. Is that accurate?
That is very accurate. And also, it depends on the cell type, because the machinery within a specific cell will dictate how that cannabinoid acts. So if it is a CB2 receptor agonist, but it is a cell in which CB2 isn't very well expressed, then obviously you're not going to see a very good anti-inflammatory effect in that cell. But if it's a cell where there's loads of CB2, then it's going to work really well. So it depends on, or if it's because it's inhibiting cyclooxygenase, so it depends on the machinery within a cell, also sometimes what the mechanism of action can be. So
we all have, I think everyone pretty much has an intuitive notion of what inflammation is. We all get bruises and bumps and things, but can you just define in a more clinical sense, what is inflammation, and why would it even happen in the first place? We always talk about it being a negative thing, but why does our body actually do that in the first place?
So a lot of the things that the body is doing, like releasing cytokines or prostaglandins in the inflammatory process, are to resolve the situation. It's because those compounds will have some kind of beneficial effect. But then the problem becomes when that goes out of control and it doesn't just resolve the situation and then go away, but for some reason the inflammatory process continues, or the stimulus for the anti-inflammatory process continues. And so you start getting chronic inflammation and a chronic upregulation of these pro-inflammatory compounds like cytokines and prostaglandins. And that's when the problem comes. I think most of us will experience, short bouts of inflammation that resolve themselves naturally, but it's when it doesn't resolve, or the stimulus that's causing it isn't going away, that you get problems. And that's when we're trying to kind of come in with anti-inflammatory processes.
I see. Can you have too much anti-inflammation?
Well, that's a good question. Well, I suppose if it's not necessary, then you can. I don't know. I don't think, I've never really thought about that before.
Like if you were taking anti-inflammatories of any kind, say such that you were preventing the normal inflammatory process from being triggered, would that be a problem?
Oh, potentially. It could be, because, as I said, some of these compounds are being released for an important reason, because they have a specific job to do in that local area of cell damage. And so if you're blocking all of those pathways, then actually the damage may not resolve the way it would naturally. So I suppose there could be. I mean, it's not something I actually know an awful lot about, so I shouldn't comment too far. But I'm guessing that there could be negative impacts of having too much anti-inflammatories. But they're only going to be anti-inflammatory if you have an inflammatory status at the time.
I see.
So, yeah.
So getting into some of the specific cannabinoids, let's just start with THC and CBD because they're the most talked about plant cannabinoids. As you mentioned, THC is the principal psychoactive or intoxicating ingredient in cannabis. CBD is not intoxicating, and it's famous for some of its medical applications, such as with epilepsy. Do both of these tend to have anti-inflammatory effects? And if so, can you kind of compare and contrast how exactly they're working and whether or not there's distinctions there?
Yeah, so they do both have anti-inflammatory and neuroprotective effects. That's been quite well documented, but the pharmacology behind it is different. So the mechanisms of how they operate are different. So for THC, it would be primarily through CB2 receptor activation because THC is an agonist of the CB2 receptor. But for CBD, there are multiple mechanisms, but it's generally not through the CB1 or CB2 receptor. Maybe sometimes some responses have a CB2 element, which is probably indirect, and we could come back to that. But other mechanisms of action have been through some nuclear receptors called PPARs, through modulating COX activity or lipox. So CB2 can modulate enzyme activity as well. So if it's inhibiting some of the enzymes that are producing inflammatory mediators, then it can block inflammation that way. The GPR55 receptor has been implicated as well in some of the anti-inflammatory effects of CBD. So the mechanisms of action are different, but they both have an anti-inflammatory effect.
I see. So just to try and tie this to like a simple real world example, I have met people at different instances of my life who might say, I might have two people that say like, I have neck pain or, some muscle in my body is sore. And then they try a cannabis oil or a cannabis topical or something like that. And for one person, it works and they say, oh my God, that was great. And for another person, they say, it didn't really do anything. Could a reason for that be that maybe the topical had, say, a particular combination of cannabinoids, or maybe it just had THC or just CBD, and the mechanisms underlying each person's inflammatory state are different, and therefore the same product might not work for two people? Is that a reasonable supposition?
Yeah, I think there's other confounding factors that could be in there as well. It could be that they haven't taken the right dose. That can often be the issue with self-medication, is that you don't necessarily know how much you're taking. It could be that the route of administration isn't appropriate. So for a topical product, I would query, do we know whether or not that topical product is actually permeating through the transdermal layer? Mm-hmm. So, if that hasn't been shown with that product, then actually you can be putting it on your skin all you want and you're never going to have an analgesic effect. So there are many kind of confounding factors when it comes to why a product will or won't work. And some of it will come down to the fact that we are very different as humans and the origin of our pain can be different. So yes, if it depends on the type of pain that you have about which compound is going to be better. So the general theory is that CBD is probably better for inflammatory pain, while THC is better for nerve-related, so neuropathic pain, particularly chronic pain. But that's a real generalization. So there are different types of pains, and because they have different pharmacology, we know the CB1 receptor is really critical for pain transmission. So if it's a nerve problem, probably THC is going to be a more appropriate product than CBD. But if you've got arthritis or joint pain or something where there's a strong inflammatory component to what's generating the pain, then probably CBD will work. And then also, everybody's just different. So, some people are just not responders to, sorry, my email's popping up here. Some people are just not responders to cannabinoids, so not everybody will find a beneficial effect from a cannabis-based product. And that's pretty well documented in the Sativex trials. So as they did more and more clinical trial work with Sativex, so that's the product that's licensed probably for the longest in this space. So it's a 1-to-1 ratio of THC and CBD. It's licensed in most countries for reducing muscle tremors in multiple sclerosis, but in some areas it's also used for pain. As they did more and more clinical research with that product, they did a an initial phase where they looked for responders and non-responders. So they would give everybody the drug, see who it worked for and who it didn't, and then take the responders and then randomize those people into either Sativex or placebo, because they basically had to enrich their studies that if you always did all your trials with just all comers, including this large proportion of people for whom this product will just never work, then you're always diluting the power of your data. So, for some people, cannabis just won't work.
Interesting. So you mentioned in there route of administration, and I'm wondering if you can talk a little bit about sort of paint for people what the contours are of our knowledge around bioavailability of cannabinoids generally, and how that varies according to how you're actually consuming a cannabinoid.
So I'll start with oral, because that's an area that I probably work in a lot, because most people who take medicines want to take something orally. It is probably the more typical route of administration for people. It's what they're familiar with. So orally, cannabinoids have very poor bioavailability. So probably only about 10% of your cannabinoid will get into your bloodstream. So
when you say orally, you mean swallowing something as opposed to putting it under your tongue, say?
Yeah, we can. Yeah. So I'm talking about orally swallowing. We can come back to sublingual, but swallowing something, probably only about 10% of that cannabinoid will make it into your bloodstream. And that's for a variety of reasons, but cannabinoids are very fatty molecules. They are not very soluble. They're not very absorbable. The ones that do get absorbed into your bloodstream, if they go through the normal process of going to your liver first, then there will be what's called first pass metabolism, and they'll be broken down. But some of them will also just be chucked back out again, back into the large intestine, and you actually excrete a lot of the cannabinoid intact because it never gets absorbed or broken down. So poor bioavailability orally. Probably the best mechanism we have is inhalation. That's why people have always smoked cannabis, is because the bioavailability of inhaled product is about maybe 40%. So it has a very different pharmacokinetic profile, though. So the compound will appear in your blood quite quickly, because it's very easy to get. It's a lot easier to get absorbed in your lungs than it is in your guts. Going all the way through your gastrointestinal system and all the hurdles that a compound has to get to in order to get absorbed is a lot more difficult than in your lungs. So you've got a very fast onset, and you get much higher peaks. So you get much greater exposure, but it declines quite quickly. Whereas orally, it takes a long time to get that peak exposure to your cannabinoid, but it also lasts for longer. So you have the area under the curve will probably be the same, but the profile is very different. Where you mentioned sublingually, so a lot of people take cannabinoids sublingually with the concept that some of them will be absorbed intraorally, so within your mouth, through the blood vessels that are in your mouth. The problem is that's not really actually been very well demonstrated to actually happen. So there isn't an awful lot of evidence that you actually have absorption of cannabinoids through your mouth. So really, the oral bioavailability is probably similar. Sorry, the bioavailability of sublinguals is probably similar to orals.
Is that because you're actually, in fact, swallowing what you put?
Because you're just swallowing them. Yeah.
So are you saying it has been demonstrated that there's not good sublingual absorption, or it hasn't been shown one way or the other?
So it hasn't been shown that there is any sublingual absorption.
I see.
So they're too big and they're too fatty to get into your bloodstream that way. So they're just, the physical property of cannabinoids don't really lend themselves to mucosal absorption. And it hasn't been demonstrated that actually happens. So when people have seen them get across into your mucosal, say across the mucosal barrier, it's taken like 8 hours. So
I see.
but things that have been shown that definitely would indicate that they're not sublingually absorbed would be the fact that the bioavailability of cannabinoids when they're given orally or sublingually is better if you eat. And that only makes sense if the absorption is GI. So it's true for any oral product. If you have a high-fat meal, when you take your cannabinoid, you will increase the area under the curve. So you'll increase your plasma exposure to the cannabinoid by about 3 or 4 fold. So
I see. So if you consume these things orally with fatty food, the bioavailability goes up 3 or 4x.
Yeah. So, and that is also true for compounds that are delivered sublingually. And that wouldn't make sense if the absorption wasn't GI, because yes. Why would food be affecting how you absorb a drug in your mouth? So I think it's just yet to be demonstrated. I'm not saying that it doesn't happen or that there aren't clever things that people, that pharmaceutical people could develop a method of getting it through the oral, intraorally, but it just hasn't been really shown yet.
One thing I want to move to, you mentioned that you had studied earlier in your career, at least, cardiovascular effects. And I'm really interested to hear you talk about the blood-brain barrier and blood-brain barrier permeability. So can you start off by just explaining for people in basic terms, what is the blood-brain barrier and what is it normally doing in our bodies? And then what do we know about some of the effects of cannabinoids on this barrier?
Yeah. So the blood-brain barrier is basically the defense between your blood and your brain. And the reason you need a defense system there is that there's stuff in your blood that your brain doesn't necessarily want to be exposed to. So you don't want your brain seeing everything that's in your blood because it would be damaging to the brain, basically. So it's a way of keeping out anything that shouldn't get past. So normally at a capillary level, where you have that kind of greatest transference of gases and substances between your blood and your tissue, the adjacent tissue, normally that's quite porous to allow for a lot of exchange. We want glucose and, everything to be passing very easily between a tissue and the blood. But in the brain, we don't want that. So we have adapted that barrier. Instead of being quite porous, we've adapted it to being a much tighter barrier. So the cells are all really tight together. And there's actually a number of cell layers at the blood-brain barrier to make that even tighter. So it's like having triple glazing as opposed to single glazing. And you've got endothelial cells from the vascular side of things. And then you've got a couple of layers of different types of brain cells as well that make this really tight barrier. And it's very much in control of making sure that all of the bad stuff that's circulating in your blood doesn't get into your brain. And when things go wrong, that can become leaky. So that barrier can begin to break down and you can start seeing holes either between cells or actually through a cell. And things like, there'll be a couple of things that will happen. You can have too much fluid leaking into the brain. So you can have edema that can cause swelling of the brain, or you can have things like cytokines or too many immune cells getting in, or, being exposed to lactate, or lots of different things that are in your blood that you don't really want in your brain. So if they get leaky, that really can damage the brain. And the blood-brain barrier does get leaky in a lot of neurological conditions. And our research looked at how cannabinoids affect the blood-brain barrier, and whether or not any of the positive effects of cannabinoids, which had been seen in some neurological conditions like stroke, could be because they were having a direct effect on this blood-brain barrier function. So we set up we set up experiments where we mimic the blood-brain barrier. In cell culture conditions, we grow all of the different layers of cells that are appropriate for a blood-brain barrier. We grow them together and we make this basically like in vitro version of a blood-brain barrier. And we make it leaky by causing a stroke within the cells. So we deprive the barrier of oxygen and glucose to mimic what would happen in a stroke. And the barrier gets leaky. And what we found is that we looked at different cannabinoids, but primarily most of our work was focused on cannabidiol at that time, because there is quite a lot of data showing in an animal model that if you give cannabidiol, that it prevents it doesn't completely prevent the stroke, but it reduces the size of the damage caused by a stroke. So that area of the brain, which would normally have necrosis, so tissue cell death, is a lot smaller if you give cannabidiol in advance. Now that's not very translationally relevant, because we don't always know when people are going to have a stroke, so it's very hard to pre-medicate them with things. But anyway, so we were looking at whether or not cannabidiol would work in the blood-brain barrier. And basically what we found in a nutshell was that it was very beneficial. So cannabidiol helps to make the blood-brain barrier tighter. So it can, if we induce that leaky barrier by inducing a stroke-like environment, then it makes cannabidiol makes the cells tighter much faster, and it reduces the inflammatory response and the cell damage caused by that stroke. And that persisted even when it worked when we gave CBD before the stroke, at the same time as the stroke, or even up to, I think it was 6 hours after the stroke was induced. And we looked at the mechanisms by which that happened, and one of the major receptors that was involved was the serotonin receptor. And the serotonin receptor is known to be involved in a lot of the the brain responses to CBD. It's like the major brain target for CBD. So it was primarily by the serotonin receptor and this other nuclear receptor I mentioned before called PPAR. So we did a lot of work on that. We also looked at some of the endocannabinoids, and we found that there were two in particular that also had this kind of protective function on the blood-brain barrier, and they were OEA and PEA, so the endocannabinoid-like molecules that I mentioned before. And then we also looked at some of the more novel minor cannabinoids. So we looked at CBDA, which is the acidic version of CBD, which is what the plant actually makes. And we looked at CBG, and we looked at CBDV, cannabidivarin, because that is a compound that people are interested in, maybe in epilepsy or other neurological conditions. And they all had a good response. I'd say the best probably came from CBDA. CBG and CBDV were also anti-inflammatory, but I don't think they were as good as CBD. I mean, the responses weren't as overwhelming as the CBD was, to be honest.
I see.
But yeah, that was quite a lot of work that we did, showing that cannabinoids in general are protective at the blood-brain barrier, which probably underpins quite a few of the neuroprotective effects of cannabinoids, if you can really maintain that barrier integrity and keep the brain from being exposed to things that it shouldn't be.
Mm-hmm. So based on what you said, is it fair to say that for CBD and some of these other cannabinoids, the neuroprotective effects are often what you might call preventative, meaning that the molecule needs to sort of be there when the insult happens to the brain, and it doesn't, does it do anything afterwards?
So it does, both cannabinoids do, but the problem is experimental studies tend to either pre-administer the cannabinoid or give it at the same time as the insult.
I see.
There's not enough researchers actually looking at what happens when you give these compounds after the problem has already been established. And I'm probably talking more about the historical literature. I think people now are doing more translationally relevant research, and they are including, doing that post-insult treatment. But it is true to say that their best effects are seen when you give them in advance.
I see.
But yeah.
So I think,
and there are situations where a problem is coming. So there are
like sports.
Yeah, exactly. So there are conditions where that's relevant, but there were, for something like stroke, that was never relevant because you never know when something is going to hit you like that. Yeah.
I see. So I think, there is, I don't remember the specifics, but, in mixed martial arts and I think American football, they're looking into different CBD-based products or sponsoring research, but that's an area where you think it's plausible where, if you know that there's going to be physical, damage to the brain that's likely to be happening, that having something like CBD in your system could actually help mitigate some of the damage and some of the risk there.
Yeah. I'd really welcome seeing that kind of research being done, because the hypothesis is very plausible, and there is animal data to show that CBD is protective in models of traumatic brain injury. Endocannabinoids have also been shown to be very protective in traumatic brain injury, and there's good evidence to show that CB2 agonists are. So we've got a lot of animal data to support that kind of research. And I think it's really important that those studies are being done. I hope they're using effective doses of CBD. I think that's, sometimes where some clinical studies fall down in this area is that the doses of CBD used are quite small. So yeah, I really welcome seeing that kind of research, because the theory is really strong, and the science that supports that clinical research is very strong.
Ballpark, when you say relevant doses of CBD, what are you talking about, and how does that compare to what's in a CBD product that you're likely to buy in a store?
So it's quite different. And so this is where this kind of, for me, there's a big difficulty in people using the evidence that we know about the clinical use of CBD into and translating that into over-the-counter use of CBD, because you're not talking about the same kind of doses. Most clinical trials that use CBD use hundreds of milligrams per day. So anywhere between 1 and 800 milligrams per day. If you are somebody who's epileptic, the average kind of dose is something like 12.5 milligrams per kilogram per day. And that is very different to over-the-counter products, where you're probably, some of the tablets I've seen of CBD are maybe only 10 milligrams per capsule. Mm-hmm. And if you remember, I said that that's only 10% orally bioavailable, then only 1 milligram of that 10 milligrams is probably going to get into your 5 liters of blood. Mm-hmm. So if you do the maths on that, what is the circulating level of CBD, knowing that the potency of CBD at any of its molecular targets is quite low, you need micromolar concentrations of CBD to have most of its biological effects, just doesn't marry from a pharmacological point of view.
Mm-hmm. So in theory, if you were to consume CBD orally, you would get more of it into your bloodstream if you ate it with a fatty meal, or if you inhaled it, say.
Yes, but with a different profile when you inhale it. Yeah.
So,
and there's other things to take into account, like the fact that there will be accumulation with time, and so, and what I would like to see is more research being done on this kind of chronic low dose CBD and what biological effects it's having. Because the problem is none of the science that's out there really supports low dose CBD. Everything that's been ever done in animal models or in clinical trials is with much higher doses. So what we need to start seeing is there a really an effect that we just don't know about that happens with low. I mean, I don't want to use the word microdosing, but using maybe up to 50 milligrams a day. Because there will be accumulation with time, and there will be changes that will happen over time. And there's definitely people for whom they're seeing drastic effects. So we just need to see some more science behind that, and it's not being done at the moment because this over-the-counter use of CBD is quite novel. Whereas the scientific research into CBD is older. That's been going on for, maybe only about 10 years, actually. I started doing research on CBD in 2005, and hardly anybody was doing research back then. Everybody was still looking at THC. There was hardly anything being done on CBD. So there's still a lot to be done. But coming back to the effective dose of CBD, I did analysis on this where I looked at all of the clinical trials that have been conducted with CBD and analysed whether they were effective. So did they meet their primary endpoint? Did they have a significant change in their primary endpoint? And the one differentiating factor between the trials that were successful and the trials that were not successful was the dose used. So if you were a successful trial, you tended to use over, I can't remember the exact cutoff, but it was over, I think, maybe 300 milligrams per day. And anything less than that on the trials were not successful at meeting their primary endpoint.
Yeah, that's what I've heard. Around about 300 is where you tend to see some effect, and we really don't have much evidence for things below that. Out of curiosity, when they do these clinical trials, do the patients tend to have an empty stomach and take just the medicine, or how does that play?
No, they will be advised to take with food.
I see. Okay.
Yeah. But there's so many things that, I think what we need to do is make CBD more druggable. So, it's really not very effective giving somebody oral CBD knowing that only 10% of that gets into them. So we need to find better ways of giving CBD, and then we don't need to give such high doses. Because if you could give, 300 milligrams of something that was 40% bioavailable, then you'd be getting, you'd be able to reduce your dosage. You'd probably see less side effects. So I think making better versions of CBD, ones that get into your system better, using pharmaceutical strategies to make better formulations of CBD, are all things that can be done to mean that the doses that we need can start coming down. Mm-hmm. But mostly at the moment, we're excreting most of it.
I see. I want to move on to a couple other topics that I want to make sure we get to. So one of them is just the general area of metabolism and diabetes. So I think a lot of times when we talk about cannabinoids, people are often talking about the psychoactive effects or the neurological or psychiatric effects. You often talk about things like inflammation, as we've done. I think an area that gets less attention is metabolism. So I'm particularly interested in the general effect of some of these plant cannabinoids on metabolism as it relates to things like blood sugar levels and diabetes application. Can you talk a little bit about what's going on in that area?
Very little. Historically, cannabinoid research is very CNS biased, because we know that a lot of what the adverse effects of cannabinoids are through the CNS. And so most of the focus has been around the CNS effects, its impact on, cognition, memory, neurological disorders. It's been very CNS biased, pain. And there has been an awful lot less research done on everything below the neck, but I think that's beginning to catch up. But probably still really not enough research is being done. Diabetes is an area that I was very interested in for a long time. There is good literature out there, animal literature, to show that CBD was effective in animal models of either type 1 or type 2 diabetes. And these are fairly old studies. I'm not talking about things that have just been recently done, but these are things that were done, easily 15, 20 years ago. So there was good data to show that CBD was effective in these models. So there was even one good study with THC showing that it was beneficial in a model of diabetes.
When you say effective for diabetes, what exactly does that mean?
So some of the things that CBD was shown to do was to reduce the inflammation in the pancreas, to improve the islets of Langerhans, to improve insulin secretion, a lot of the research was also about resolving a lot of the comorbidities associated with diabetes. So the other problems like neuropathy or glucose handling or impacts on the heart. So a lot of the, or impacts on the vasculature, that was research that I did, was we looked at how your blood vessels function, which is worsened by diabetes. But if we gave the animal CBD, that was improved. So vascular function. So there was lots of kind of secondary impacts of diabetes that have been shown to be improved by CBD. So we, in collaboration with GW Pharmaceuticals, about must be 13 or 14 years ago, did a trial in type 2 diabetes off the back of all of this literature that was suggesting that there was a positive effect of CBD. And also another compound we were interested in was a compound called THCV, tetrahydrocannabivarin, which is, of the THC family. But instead of activating the CBD receptor, or the CB1 receptor, THCV actually blocks the CB1 receptor. And it was already known that blocking the CB1 receptor has quite good cardiometabolic impacts. So there was a drug on the market for a while called rimonabant that was a CB1 receptor antagonist, and it was a very effective anti-obesity, anti-diabetic drug. But it was able to penetrate the blood-brain barrier, get into the brain, and it also blocked the CB1 receptors that was in the brain, and that didn't have a good consequence. So because our CB1 receptors are so critical in neuronal function and in well-being, there was a major side effect of low mood, depression, and even suicides with this compound. And THCV was suggested to be an alternative to rimonabant, because it's a different type of CB1 blocker. So I won't try and go into that because it's quite complicated, but it blocks the CB1 receptor, let's say, in a more gentle way than rimonabant. Okay. And so the theory was, well, maybe we could use this plant-derived compound as an anti-obesity drug as well. So we trialed them both, and we trialed them individually, and we trialed them in combination. And what we found, disappointingly, I'll start with CBD, was that we didn't see any impact. So we did 12 weeks of treatment, but we only did 100 milligrams twice per day. Okay. And that, we know in hindsight, was just not enough. So this was early days for CBD trials. I mean, we published it only about 3 or 4 years ago, but the actual trial was initiated a good 12 years ago. And I think we just got the dose wrong, to be honest. I still believe that there is a potential for CBD and diabetes and weight loss. I mean, weight loss is one of the major side effects of CBD drugs. But it's just not. Yeah.
So a side effect of Epidiolex is weight loss?
One of the main, So loss of appetite and loss of weight is a significant side effect. There's a company trialing CBD for Prader-Willi syndrome because of CBD's effect on appetite and eating. So Prader-Willi syndrome, I don't know if you know it, but it's that genetic disorder in children where they have hyperphagia, they can't stop eating. And so people are looking at whether or not CBD could actually be used in a condition like that to try and reduce appetite and help that condition. So yeah, I still believe in CBD, but I think we got the dose wrong in that study. But we did, on the positive note, see a positive effect of THCV, in that we saw a significant reduction in resting blood glucose in the type 2 diabetic patients. Unfortunately, though, that research isn't really going anywhere anymore. GW didn't pursue investigating these compounds in diabetes. They moved. That would have been around the time they started doing a lot of their Epidiolex studies in epilepsy.
I see.
And they've become very focused in that area.
It sounds like they didn't pursue it because they had this Epidiolex thing they were working on. Maybe they wanted to focus on that, not because it wasn't looking promising.
Exactly. So
and is that also 100 milligrams? What was the dose for THCV?
No, that was 5 milligrams.
5?
Yeah.
Wow. Well, so that's really interesting because that's a workable dose that someone, could encounter out in the real world, quote unquote. Whereas, 300 milligrams of CBD. I
may have to check myself on that. I'm sure it was only 5 milligrams. Anyway, I'm just gonna Google myself there, but yeah, I'm pretty sure it was like 5 or 10 milligrams, but because it's more potent, than CBD is.
Interesting.
You only need 5 milligrams of THC.
But in any case, it was a lower dose than you did for CBD, and you saw a positive effect. It actually lowered blood sugar levels in people with type 2 diabetes. Yeah.
So 3 months of treatment. Yeah. If you look at epidemiological data on people who smoke cannabis, there's more often than not, there is a positive effect on cardiometabolic status. So cannabis users tend not to be obese and tend to have better blood lipid profiles and just general kind of cardiometabolic profiles. So there's definitely, they're not overweight and diabetic, that's for sure.
Yeah. I mean, that's sort of interesting. I don't want to spend too much time on it in the time we have left. And I know that there's probably complete answer here, but I'm sure you're referring to cannabis users, meaning people that are consuming predominantly high THC products. And THC is famous for having, eating junk food as a side effect, basically. So how would you even start to think about that? Those two things would seem naively to be in conflict.
Yeah, well, the story about THC and feeding is more complicated than just it stimulates appetite. So it does. So if you will have an acute response where you want to eat, and often that is high fat, high sugar foods. But if you look over a 24-hour period, people don't consume more calories than they would. So they eat, but then they don't eat for a while, and then they eat again. So it's not inducing overeating.
They're just packing all of it into one bout of feeding. Yeah.
And with chronic use, there can actually be a weight loss effect of THC. So I've seen data where THC was given to obese animals and chronically will cause a weight reduction, because THC also acts at other receptors that actually have a weight reduction effect. So it's not that THC doesn't necessarily, in people who are, let's say, of normal weight, cause an increase in weight. But where it can cause an increase in weight is in conditions where there is wasting. So in AIDS-related wasting or in cancer-related wasting, THC, and usually in its synthetic forms in nabilone or dronabinol, has been shown to stimulate appetite and increase body weight, or at least stop the reduction in body weight that would be seen in those patients. So it is licensed in America for HIV-related wasting.
Interesting. I didn't know. I don't think a lot of people know about that research.
But that's one of the oldest things that a cannabinoid has been licensed for. So that licensing was in the 80s, because when people started looking at the biological effects of cannabinoids, that stimulation of appetite was one of the things that was very obvious, and it was one of the things people did research on.
Yeah,
and its ability to suppress nausea and vomiting as well. So the licensing for chemotherapy-induced nausea and vomiting has been around for a very long time.
Yeah, I mean, that part makes perfect sense. So what you're saying is that there's at least some evidence out there, some in humans, some in animals, that THC can actually stimulate weight gain in wasting conditions where you're underweight, but actually potentially do the opposite in other circumstances.
Yeah. Yes, that's exactly right. Yeah.
I want to talk a little bit about permeability in the gut. We talked about the blood-brain barrier.
We're definitely jumping all over the body here, aren't we?
Oh yeah. Well, I want to get to all the major spots. What can you talk to us about in terms of like gut health and gut effects of some of these cannabinoids?
Yeah. So I think my research on gut permeability actually preceded my research on blood-brain barrier permeability. So I started working in the gut first, and then because it was very good data, which I'll come to, that's why I ended up moving into the blood-brain barrier as well, because we had a lot of data under our belt about what these compounds do in the gut. So we've got the same kind of barrier system in the gut, where things that are inside your intestines, we do want to protect your body from some of those things, because there will be things in there like bacteria, for example, that would be quite dangerous if they were able to cross the intestinal barrier into your bloodstream. That could cause inflammation. But the gut barrier is a little bit different to the blood-brain barrier. It is just a single layer of cells, but they're tall cells, they're columnar cells like this, and so there's a bit more bump to them. So instead of being like triple glazing, it's just like having really thick blocks, and they can become leaky. So again, either between the cells, that kind of junction between the cells where normally they're really tight together, that can become leaky, or you can have substances passing through the cell itself. So we did a lot of work on inducing permeability in an in vitro model of gut permeability, where we basically we treated them with cytokines. We made them inflamed, and that increases causes a leaky gut. And then we looked at different cannabinoids and what they did. And we found that both THC and CBD were very effective at stopping gut permeability that we induced by inflammation. So they helped that barrier to get back into shape much faster than it would do by itself. And there's lots of other data. We also did data on bits of samples. So I was very fortunate that my office was next door to a gut surgeon. And so we got lots of bits of tissue from people who were having parts of their intestine removed. So they were IBD patients, or they were patients with appendicitis. And so we had samples of normal gut from patients, and we had samples of inflamed guts from patients, different types of patients. And in those patients, we found that CBD was very anti-inflammatory. So we could reduce the amount of cytokines that was being produced by this inflamed tissue. And we mostly just looked at CBD in those studies, and PEA, which is that palmitoyl ethanolamide. We didn't look at THC in any of those human tissue studies, but we looked at the mechanisms of how they act and how they stop the basal production of cytokines, and also if we made them even more inflamed by putting on more cytokines, how they reduced the inflammatory response to that. So that is supported also by lots of other people's data, where they've given, these compounds like CBD and PEA to animals, to whole animals that are models of colitis or IBD, gut inflammation. And they have all shown that cannabinoids are very effective at reducing gut inflammation, and reducing gut permeability, and basically improving the indices of inflammatory bowel disease.
Interesting. So in the time we have left, I want to give you space to talk about a different kind of topic. So at the very beginning, you mentioned something that was interesting to me. So you mentioned that you used to work in academia and now you work in industry. That's actually not the part that I found interesting. It wasn't that you did your PhD and then said, oh, this is not for me, I'm going to go into industry, or then did your postdoc and said, this is not for me, I went into industry. You actually ran like the full gauntlet. You became a professor. You sort of got to the place that every aspiring academic is aiming for. And then you made the transition. So can you talk to us about how that happened and why you made that choice?
Yeah, it was really interesting. And it was literally 1 month after I was notified that I was promoted to professor that I handed in my notice. And it shocked a lot of people. And I don't want to get too personal about it, but I definitely feel like I had run my course with academia. I love research. I absolutely love research, and I love working with students. But there is a certain slowness to academic research that I found quite frustrating. So things don't really move at much of a pace in some area, not for everybody. And I felt like I could make a difference, a bigger difference somewhere else. And there were other aspects of academia that were bothering me. And I thought that when I was made professor that it would make me feel differently about the university, but it didn't. And for me, that was the point at which I knew I really have to go and do something different, because I thought, this hasn't made me feel more in love with academia. And I thought it would. I've gotten to the point where I thought I, wanted to be, but actually I really do want to go out there. I want to do something different from a personal challenge point of view, but I also want to feel like I'm making more of a difference. And I think I didn't feel like I was making enough of a difference in academia, because, your time is always torn between so many other endeavors. When you're an academic, you're a teacher, you're a mentor, you're a HR expert, you manage budgets, you're trying to do your research, you're trying to be collegiate, running timetables, modules. You're just being torn all the time. And I felt like I would rather be more research focused and actually not have some of those challenges on my time. So yeah, they were the things that motivated me to want to leave. And I also thought, well, I have enough time in me that I could make a start on a new career. I think I felt that if I stayed any longer, I probably would never leave. So that felt like a good time to go. And then the other big thing that was happening at the same time, which was very serendipitous, was that there was just this, I feel, a huge sea change in all things to do with cannabis. Mm-hmm. So in the last five years, at least in the UK, we have seen things change at such a rate. You know, we've changed the law about medicinal cannabis. There's been a real change in public perception and acceptance about the therapeutic utility of cannabis. There's been a real flurry of companies that are interested in doing cannabinoid research. 20 years ago, there was none of this. You know, 15 years ago, people were not interested in talking to me about cannabinoid science, whereas now, you know, you've suddenly become really popular because you know about a topic that is having a heyday. And so I felt like there was a wave, and I wanted to be on that wave from a different angle, that I wanted to be part of the movement, and that maybe a different place to do that was in a commercial setting. So all of those things kind of happened at the same time, and, you know, probably in a different set of circumstances I would have stayed, but it just seemed right at the time. So I decided to go out by myself and do consulting, because I had already been doing some consulting on the side, because some companies had been approaching me for advice, because I did gut work and stroke work and, you know, cancer work. And so I was giving advice to people. And so I already had my foot in the door, and I thought, well, I can do more of this, and let's see how it goes. Mm-hmm.
So let's talk about consulting for a second, because it can be this sort of this amorphous thing. You say, you know, I'm consulting for people. Like, are they literally calling you on the phone and saying, tell us about how THCV works, please? Maybe for the people that, you know, might be academics now that might be curious about consulting, can you give us an example of like a representative consulting project? What are you actually doing and delivering?
Yeah. It was really interesting, because I wasn't sure what I'd end up doing, but the typical thing that people wanted from me was to know what the evidence base was. So they might have a particular compound that they were, you know, they owned, or they were interested in licensing. And so they would want me to say, call a compound X. They would say, tell me about compound X. What is the science behind it? What does the evidence show? You know, what would be a good home for this compound? Like, what indication, what disease should we be thinking about? What would a clinical trial look like? You know, so sometimes I'm saying, okay, well, this is what your trial should look like. These are the patients you might want to do. So it's that kind of whole, you know, looking at the evidence base and giving advice on how you could potentially move that compound into a clinic. Mm-hmm. Or it could be just about a disease area and what the general evidence is for cannabinoids in a particular disease area, and then helping people, you know, understand what the right compounds might be by knowing the science and the mechanism of action of lots of different compounds. And you can figure out, okay, in acute kidney disease, it's really CB2 that you want to be targeting. Mm-hmm. However, whatever you do, however your compound works, so this is the molecular target, so this is what you want to do. So a lot of the research was, a lot of the work that I did was kind of commissioned reports like that, where I would, you know, really get nitty gritty into the science of what was already published and put it all together for them, and present options to them about, you know, how they might go forward. Sometimes it was just about education. So going into companies and teaching them the basics of cannabinoids, about how they work, the history of them, you know, all the different ways that they're different, you know, like how we started this conversation today. But just like really giving them that cannabinoid 101 is quite important to people who've never worked in this area before. It's a complex area. And so having somebody who is an expert who can kind of break it down for them was something that was, you know, really worthwhile doing. I also did a lot like talks for people. So going into, you know, on their behalf, you know, speaking to societies or at conferences, at organized events, where I would go and do education pieces on, you know, any of those above things. So there were lots of different, you know, maybe talking to the media. I'm trying to think of what some of the things that I've done.
But if I could summarize so far, what you are telling us in effect is that as a biologist with your kind of background, you are getting paid professionally to read, comprehend, and summarize the literature for people, and to give talks, educational talks to people.
Yeah.
So a subset of the things that an academic would already be doing.
Yeah, exactly. So I wasn't doing anything different than my skill sets. But what was different is that you're putting a commercial spin on it. Mm-hmm. So sometimes I'd be looking at what the competition is. Who else is out there doing this? What clinical trials are being run already? What companies are out there doing what? So sometimes it's more commercial than that. But yeah, I've got to read more in the last couple of years than I think I did in the last 10 years in academia, mm-hmm. when I was doing research as an academic. I've actually probably learned a lot more in the last 2 years about areas that I never worked in before. So I feel like I have a much broader understanding now than I ever did. So it's been really great. I've definitely found it really educational, and I've really enjoyed it. And what I found is that there are people out there who want expertise like this. I've never had to advertise. Mm-hmm. I've never, really, it just kind of word of mouth. I'll get a phone call from somebody saying, oh, I hear that you can give advice on this kind of thing. And that's how it's happened. So it was an interesting journey, but I have now taken a permanent role so one of the companies for whom I was doing science advising for the longest, probably for 4 years, is a small biotech company called Artello Biosciences. And they recently offered me a permanent role. And so I'm now working for them, not on a full-time basis, but almost full-time, but doing the same thing. So really being that translational, expert about helping turning science into medicines, knowing all that into nitty-gritty cannabinoid background that's in my brain from the last 20 years and using all that knowledge to help them move their products forward in their development plan. So that is great for me because it's real, it's tangible. There are medicines being made, there are trials being done, mm-hmm. and there are hopefully people who are going to benefit from it. And that was always what my goal was. And I feel like now I'm possibly getting to that point quicker than I would have done in academia.
Yeah. So you mentioned earlier the slowness of academia, and you touched on right after that, getting pulled in so many different directions with so many different responsibilities, scientific, administrative, and otherwise. Is that where the slowness comes from? What do you think causes this sort of the pace of academic science? What's your diagnosis there?
I think it is all of those things. I think that getting the kind of funding that you need to do fast-moving research is difficult. I was never a massively successful grant, awardee. I did get money through my time, definitely, but I wasn't one of these people who was getting £1 million grants. So I was always looking for money. I could have done bigger, better research had I had infinite, funds available to me. And I'm sure every academic would say the same thing. So that was always a massive rate limiting factor, that you were doing things not as fast or using the latest technology. I went into a clinical research organization a couple of weeks ago. So this is somebody who we pay to do our research now. The machines and the technology that they have and the high throughputness, if that's a word, of some of the stuff that they're doing is unbelievable. Academia just can't compete with that. You can screen your compounds so fast with some of the technology they have. And there we are in my lab with these old, plate readers that are 20 years old, and the one PCR machine, and, 2 cell culture hoods that everybody's fighting over. It just, it just can be a different world. And I think that there's a lot of, brilliant people in academia who would have made bigger and better discoveries if they had just been easier, and they had more funds available to them.
Do you think, this is do you think I don't mean this in the sense of there shouldn't be people getting this type of training as much as possible, but do you think there are too many science PhDs in the sense of there are too many people fighting for the same finite pool of resources, and that paradoxically you might actually be able to move faster if you were able to get more funding per lab?
I don't know. That's really interesting. I mean, I'd hate to say that there's too many people being trained, because everybody who has a good scientific mind should be using it. I think there's limited resources. I think, I think I'd blame that one before I'd blame there being too many people. But I understand where you're coming from. There are currently way more brilliant people out there than there is funding. I mean, if you are somebody who's writing grants, most of the time you're getting a grant rejection. The feedback is, this is a great study, but it's just not a priority. So the problem is you're putting your science in there with other great scientists, and it began to feel like you had no control over whether you got funding anymore. Being an excellent scientist just wasn't good enough anymore, because everybody is excellent. So you're in a pool full of people who are scoring really highly. Everybody's scoring really highly. So what differentiates you? And 10 years ago, as a cannabinoid scientist, we weren't getting a lot of funding. So that might be different for me now if I was in academia, where I'm suddenly working in an area that's more sexy than it was 10 years ago. So it could be different for people in this space now. But I know a lot of brilliant cannabinoid scientists who pretty much left doing cannabinoid research about 10 years ago because it was just too hard to get funding in that area because people didn't really see it going anywhere. So I think there's just not enough resources out there for people. I did see another interesting conundrum similar to the one that you put to me recently on Twitter, where somebody said, if there was less science out there, we'd be able to concentrate on the science, the little science that was being produced better. But because there's so much science being produced and published all the time, we can't keep track of it. And we're missing some of the gems because of the sheer volume of research.
Did you, on that note, did you see the recent PNIS paper on this topic?
No, I don't think so.
I haven't dissected.
Maybe that's what was being talked about on Twitter.
It could be. So it was making the rounds recently. I have not dissected it thoroughly, but basically the gist of it is what they found by analyzing a large corpus of literature across many fields is that as any given field of science gets bigger, as measured by like the total number of papers being published, the field basically moves slower. And I believe the measure for that was like there was, as the field gets bigger, there's more and more inequality. The Gini coefficient of the citations goes up, meaning that people just keep citing the same pool of like mega papers, and effectively, the ideas really do become entrenched by that measure, at least.
Yeah.
It's interesting.
Yeah, I mean, it is a really interesting concept. Yeah, and
you see this in the private. You can't
keep up with the volume of research anymore. I used to know all of the cannabinoid researchers. A paper would come out and I knew the names. And now there's so much stuff. I get these alerts from PubMed. There's so much research coming out. I can't keep track of it all because it's coming out, faster than I can read and digest. And I don't know any of the people anymore. So I definitely feel like I'm losing a handle of some parts of the research, but that's not necessarily a bad thing.
Yeah. When I fantasize about this stuff, sometimes, I imagine an alternate universe where, an academic is not applying for a grant like every goddamn year over and over again, but an individual is simply awarded like a perpetual grant, say, and, for the next 25 years, you're going to just go do your thing. And this is it's sort of like you're getting 25 years worth of grants all at once as an individual, rather than having to have a different group of your peers justify this one set of experiments twice a year, every year ad infinitum.
Yeah. And we waste a lot of our time writing grants. I felt like that was one of the most unproductive uses of my time, writing grants that didn't get funded, rewriting them, just that whole process. It takes more time than it's worth.
Yeah.
And
it really does in many ways remind me of the private sector in the sense that, when you talk about disruptive innovation, right, the story is always, the small unknown startup disrupting the incumbent, because as organizations get bigger, whether it's government, whether it's a corporation, whether it's, our academic institutions, there's just more administrative structure there, and it just sucks away time from the actual thing you're trying to do, and you just move slower.
Yeah.
Anyways, we have a few minutes left. Any exciting upcoming areas of cannabinoid research that you're working on or that you're watching that you think are going to have some interesting insights that come up?
Yeah, that's an interesting one. Like, what's going to be the next big thing in cannabis medicine? So there's an awful lot of stuff that's kind of at phase 2, so still small clinical trials, not quite moving forward to potential licensing. So I'm not sure what's going to be new in terms of what medicine is going to be next to be licensed. I don't think I could put my money there. But I think what there is definitely a much bigger number of clinical trials being carried out than there ever was. So I think that we will see a change in the next kind of 3 to 5 years in terms of what's available for licensed cannabinoid-based medicines. And I think that there will also there's not as much research, I think, really just being used on medical cannabis as a whole plant product, because people aren't, from a commercial point of view, it's not patentable. People aren't investing the kind of money to do big trials in that type of research. So I don't see an awful lot of big headlines coming out from whole plant products. I think that the kind of the short term future is going to be more about specific and patented products in terms of the therapeutic use of cannabis-based medicines. But there's an awful lot of, it's hard to choose one, but there's an awful lot of, and I don't want to choose one and appear biased by choosing something from the Artello portfolio. But there's a lot of things out there that, as I mentioned with the sports story, there's a lot of things out there that have a really strong scientific background. They're being pursued in, good clinical trials, randomized controlled trials of decent patient numbers, that if they're successful, could really change the face of things in the short-term future. So I find that very positive, and I think that the future of cannabis-based medicines is really bright. There's lots more companies coming into the area, looking at really putting their thinking hats on and saying, what can we do differently? How can we do our trials better? And how can we be smarter about the products that we're using and the indications that we're using, and the delivery mechanisms and the formulations. So I think as more and more kind of pharmaceutical type companies get involved in this, we'll see more innovation in this area. And I think we'll start to see the utility of cannabis being actually utilized. So, people have said that cannabis is like a Pandora's box of medicines. I totally believe that. I think it's tapping into it that's always going to be the difficult thing. But I'm a lot more hopeful now than I was 5 years ago, because there has been this, great flurry of companies trying to now actually use that knowledge and produce something. So not a specific thing, but just in general terms, I'm very optimistic for cannabinoid-based medicines.
All right. Well, Saoirse O'Sullivan, thank you for your time.
You're very welcome. Thank you very much.